Hey guys, we're going to go back to this part here. I have my piece in the lathe. So what they have here is they have drilled down through the top of this. Take the screw away. And they've drilled into this pin, and then they have a little spring down in there, and a little sliver of brass slug in there, and that brass is pressed up against these threads to lock them in place to keep them from vibrating loose, and because this is what is holding your fixture from moving. You're on the indexing surface. So I got a little piece of spring material, some spring steel, and now I just can't make a spring that small. So what I propose is I'm going to drill and tap this. Well, I think I'm going to drill it first for this piece of brass, and then I'm going to counter bore it, thread it, and put a set screw in there to put pressure on that. Now the other option was going to be to drill and thread it and actually cut a groove, cut a slot on the top of this, and just crank this with a screwdriver to give it pressure against that screw. So basically I would just make a threaded rod of this and just thread that in. And like I said, just cut a groove in there and use one of those micro screwdrivers to tighten it up. Because I'm thinking if I put that in there and then do a counter bore, I guess I can still exert pressure on the end of the piece. I like the idea of having a set screw in there better, actually. And the piece of brass doesn't have to be very long. It can be literally a millimeter long. It doesn't. It has to stick up enough. It has to stick up into the counter bore enough to where the set screw is going to, even be able to come in contact with it. So it's going to have to go in there a little proud. So I'm going to think about it for a little while and decide what route I want to go. And yeah, it shouldn't be, either way should be easy peasy. I'm thinking of what I'm going to use to cut that groove for a screwdriver slot. And then you could always use a I just think a hacksaw blade might be a bit much. I thought I had a piece of material in here that I'd done that to. Yeah, I do. Let me get the magnet. So I actually have one of these I've already made, and I think that's 10/32, and it's got, So if I went with a piece larger than this, well, I can't go too much larger. Yeah, I can go quite a bit larger, because this thing, the screw, I mean, I could probably go almost up to half the diameter of this screw. So I need to go up a size from this. Okay. Well, like I said, let me think about it, and we'll get back with you when I decide which way I'm going to go. It's nice to, I have things in here I forgot about. So, nice to go through your tools now and then just to refresh your memory. Alright, I'll bring you back when something starts happening. Okay, here's the plan. I'm going to drill and tap for 8/30 seconds. And I'm going to screw this piece here. I'm going to screw that in there. Leave a millimeter sticking out. And put a slitting saw in the chuck. And just hold the, just bring the, just bring the part to the saw and cut a little slot for a screwdriver, and then we'll screw that on down. Let it stick a little bit proud. Force this screw through there, get some grooves in that piece of brass so it can grip. Okay, that's what I got, so I'll bring you back. Okay, I have a slitting saw in there. And now I'm thinking I'm just going to cut a groove in here for a micro screwdriver. Dogs are going nuts. About 100 RPMs. Let me find a comfortable spot here. I'm going to put on the Magnavision. I'm going to go shut these dogs up.
Let's go! Let's go! Yeah, let's go! Yeah! Let's go! Let's go! Go!
Okay, I hope you enjoyed that. Find a way to get my arm inside here. Pull this tailstock. See if I just pull the chuck. Give me enough room. Okay, put chuck key up there. Okay, Magnavision. Okay, the blade has no grip in there. I remember what I've done in the past. I've put paper in there. Okay, got to start. Now, what I need to do is back this off. Compelling video, huh? Okay, I got a couple pieces of 1000 grit automotive sanding paper. And tighten that up. Okay. Back on with the Magnavision. Let me find my my focal point. See how deep that is? Oh, that's plenty deep. Let's get a screwdriver on that. Give you Okay, everybody's got a pack of these somewhere. Oh, those are all, no they're not. Thought they were all Phillips. These are a Stanley brand. So let's bring this out here. Okay, we are now interfering with those threads. And that's kind of what we wanted. So let's back that off. I want to still see it, because I want to push the threads through that. To kind of lock them in. Yeah, that might be asking quite a bit. And that's still quite a bit. Okay, that's good. You'll put that on a vise and turn that in all the way, but I think that will suffice in keeping that in contact and keeping the parts from backing out, the screw from backing out. So there's the rest of that one. And if I can find a spring, I'll cut this thing off. And we'll go in from the bottom. Okay, that's it. Let me get that screwed on. I guess I'll have to give that a little tighten every time you get it in position, but I screwed it on through there and got it moving freely. It was tight, but now I just gave that just a little bit of a turn, and it's tightened up. And you know what? If it doesn't work, we're no worse off than we were when we started. But I think that's fine. You might have to tighten that up. Just turn it minutely when you're setting a job up. Yeah, it feels good. Okay, it's Kimberzelik here. Welcome to my channel. And so, I'll go ahead and show you how this actually goes on here. So this is a radial grinding fixture. So to mark that location, you want to put that in there, and come around to the other side and do the same thing. And if you need to move it, see it moving, it's tightening up. And okay. So basically, It's a little give and take between those two screws till you get that where you need it to be. I can't see the mark. We're off our 0. So it's the same application here. I can I'll back this off and crank. Okay, and then actually take this out and put this one right here. And we can catch that. I think you're getting the picture here. It's need to shorten this one up quite a bit. And that takes that table out. Two and a quarter degrees, I guess. These are taper in inches per foot. So this is 2.5 feet per foot taper. You can see the table is definitely cocked. So that's kind of how those work, in case you didn't know. Have I showed you my drift? Sure I have. Okay. Here's the Harbor Freight 6x something bandsaw. I got the elevation plate coming from Mr. Pete. I saw that video when it originally came out months ago. Almost bought it because I knew I'd have one of these eventually, and he talked me out of it. He said, wait till you get your saw. And of course he was out of stock soon after that, not making any more. And 3 days after I brought this home, he announces that he is selling elevation plates once more. And I'm really grateful because the guy who I bought this from, he has everything set up very well. So buying this used, and used literally one time, I benefited from it being all put together already for me. And you know, all the adjustments to the blade, you know, it cuts square, and the guy did a great job putting it all, getting it all right. Now I'll have to learn how to do all that eventually, but at least I can get a clean start with as far as this machine goes, accurate cuts. Let's pull this piece out of here. This is the piece that I cut, it had some grease on the blade. This was the first cut. The blade was coming in contact with a guard and a bearing, and then I turned it around and did this cut here. So it's not bad for, I think they sell for about $250. I got mine for $175. It's hard to justify that because, I'm not working with square stuff that often. I don't have a mill. And anything round that I need to cut generally isn't greater than 1.5 inches. And I have a hacksaw that'll go through just about any of that stuff. And here's a curiosity, if anybody can identify this one. Kind of a spoon looking kind of thing. It puts me in mind of molding wax. It could be a woodworking tool. As far as sharpness goes, it's not really sharp, but it's capable of being sharp. No doubt about that. Anybody know what I got? Okay. Tangent 2. Shut up. Quit talking. Thanks, guys. Like and subscribe. Tell a buddy. Bring a friend.